Number 8. Number 8. All right. For number 8, the common denominator is 4x to the second. Okay. And so we've got 1 over 4 times 4x to the second minus 25 over x squared times 4x to the second. X minus 10 over x times 4x to the second. Am I good so far? Okay, you guys tell me if I make a typo. The x squareds cancel, and x cancels. Okay, so I have x squared minus 100. Okay. Did anyone figure out that if we have this on the bottom, we should just leave it and just not distribute because we're just going to have to factor it again? Okay. Yeah, and then eventually you go, wait a second, I distribute, and then I just have to factor it again. Yeah. All right, so on the, yeah, I distribute, and then I undistribute. Yeah. So then on the top we have x plus 10, x minus 10.
Yep. So where does that 4x to the second come from?
It's probably a typo.
And then there's another one that was a typo too.
There's 2 typos? You guys. How sad. Okay. So what was the typo on the answer key? Oh, no. Okay, what letter is it?
No, it's 4x squared.
P? Oh, no.
Also a typo because it should be a minus instead of
And that's what I thought.
What number?
14.
14?
X minus 4 and x plus 4.
Wait, I did it. I did it with 4th period and got x plus 4.
Yeah.
4th period, we did that problem.
I thought it was a typo at first.
Oh, I see what.
Okay.
Yeah, I got it.
Yeah. Yeah. Whew. Okay, only one typo?
Only one.
Whew. All right. Okay, that's not terrible. There's worse things. Okay. Okay. All right. Complex fractions. How do we feel about them?
They're pretty good.
They're pretty numbery.
Very numbery. Room for error, but if you, but not. Are we still in agreement that the common denominator was the worst day?
Yes.
Still in agreement? Okay. All right. Let's make a pile of these, and then let's get out a piece of paper to take some notes on. No. Marvelous. Yes. Do you want to do it during enrichment? Let's do it. Okay. All right. All right. Yes. Okay.
Oh, by the way, I really enjoyed your pun.
Thank you.
Algebra is so basic though. Like I knew that after like 3 Yeah, like because I have a paper that I need to go in school, but I had lost my. I found him. Can I didn't know you needed a signature. I didn't get my mom to sign it.
All right. Today we are solving rational equations. Solving
So no more fractions?
rational. Yeah, sorry. Fractions are the entire unit, so we're gonna.
We've been solving rational equations all the time now.
No, we've been simplifying rational expressions because we haven't had any equal signs. Today we have an equal sign. Yeah.
So is this harder than what we've been doing?
No, we already had the hardest day.
Okay, good.
that the?
The common denominator day was the hardest day.
When was the common denominator day? My days get confused.
That was the day before the quiz.
We do so much math in this.
I know, we do so much math.
It just gets jumbled together because it's like a new thing every day.
It's wild, isn't it?
It really is.
Okay, I'm going to start you guys off on a problem that's going to use your common sense, okay? So if we had 1/7 plus x sevenths equal 5/7,
Oh, 5. See, common sense.
then what would the x be? 4.
Oh, you add. Oh, it's plus. Oh, See, no common sense.
Whew, that concerned me, but it's fine. We're moving on.
Because the X is funny.
Yeah. And it's because it's an addition problem, right? So you have to have common denominators. So if your denominators are all the same, then you can just say, oh, 1 plus x equals 5. And then your x would just be 4, right? So now none of us probably did this math, but what we could have done, is everybody listening? What we could have done is multiplied all of these by
And
7.
then it would cancel out and you would just get left with the numerator. And you just get left with 1
Yeah.
plus X equals 5.
Yeah, because if you multiply all of these by 7, then exactly what Holland said is true. 1/7 multiplied by 7 is just 1. X sevenths multiplied by 7 is just x. 5/7 multiplied by 7 is just 5. And if you have 1 plus x and you subtract the 1 over, then you get x equals 4. Wait, were you gone yesterday? So late pass? Okay. All right. Does that make sense? Are we following along with that? So this is the basis for how we're going to do all these problems, which means that what we learned yesterday about finding a common denominator and then multiplying by the common denominator is actually the same thing that we're going to kind of do today, just slightly different. But it's going to help us with today.
Couldn't you technically just multiply both denominators by each other and simplify like later on?
Yes, but sometimes doing that makes the problem really intense. Which is why instead of having you guys do that, I had you guys pick out the things that were the same, because when you pick out the things that are the same, it keeps the denominators small. And if you multiply the denominators together, sometimes they get so big that you can't do the problem because you end up with something in the numerator that's bigger than you know how to handle. Does that make sense?
Whenever I couldn't figure out where I wasn't 100% sure about the denominator, I would
Just multiply them together.
together.
Yeah. So it works if you end up with a numerator that's like a squared or a cube, but sometimes students would multiply the denominators together and then their top is like to the 5th.
Yeah.
We don't know how to factor that.
Yeah, that's not good.
So sometimes you're okay, but sometimes you're not. And instead of teaching you guys a process where I say, so sometimes this works, and then sometimes you shouldn't do it, and then sometimes that's not helpful as a teacher to teach students something that only sometimes works. I'm going to teach you the thing that works every time, and I'm going to teach you how to keep things simple as opposed to like teach you a rule that only works 30% of the time. Yeah. So, all right, so let's try another example using this same idea. So we have 1 plus 1 over r minus 1 equals 4 over r minus 1. Now, one thing that we have to keep in mind when we're doing problems is that we have to make sure that when we have a final answer, our final answer cannot be an excluded value. And most of the time, the final answers are not excluded values. Like, I would have to specifically choose a problem on purpose where the answer is the excluded value and make that one where I'm like, I'm going to make sure they check for it. But every so often, it happens. So maybe, I'm just saying. So if we look at this, can anyone tell what the excluded value is for this problem?
Positive 1.
+1. So we're going to say any answer is okay for this problem as long as it's not +1. So we can have 5, We can have 7.2. We can have negative pi. We can have negative root 3 over 7. We can have literally any answer in the world you could possibly think of, but if we have 1, it's a no-go. Now, if we get 1 as an answer, if 1 is our answer, then we say no solution. Okay? But if we get literally any other possible number you can think of, any other number would be fine, just not 1. Yes? Because 1 minus 1 is 0, and you can't have 1 over 0. You can't have 4 over 0. Those are the things that give your calculator an error message. So we want to make sure that that doesn't happen. Okay, so our common denominator here is what? R minus 1. It's the group R minus 1. So what I'm going to do is I'm going to take my entire equation and I'm going to multiply it by R minus 1. So I'm going to have 1 multiplied by R minus 1. I'm going to have 1 over R minus 1 multiplied by R minus 1. And I'm going to have 4 over R minus 1 multiplied by R minus 1. So in the first piece, nothing cancels. I just have 1 multiplied by R minus 1, which is just R minus 1. In the second piece, the R minus 1s can cancel, and I just get 1, so plus 1. And then the R minus 1s over here are going to cancel, and I just get 4. Yeah, so now I'm solving a very easy equation. R minus 1 plus 1 equals 4. And so, yeah, those two cancel with each other. R equals 4. It was a typo, it's fine. R equals 4, we got it. We knew what you meant. Now, 4 is not the same thing as 1, and so we're good. R equals 4 is a great answer. Cool. Yeah. All right, let's try another one.
It just cancels out so nicely.
Okay. 4n plus 24 over n plus n minus 4 over 2n equals 1 over 2. Okay, so first thing we're going to say is what our excluded value is so we can make sure we don't get that answer. Okay, so n cannot equal 0. Let's make sure we don't get that answer. Not 1/2, just 0. Because 2 times 0 is 0, 0 is just 0. So both of these give you 0. Our common denominator is 2n. All right, the constant whispering is driving me crazy. The constant whispering, mostly from this direction, is driving me crazy. All right. Okay, so we're going to take the entire equation and we're going to multiply it by 2n. Okay, so I've got 4n plus 24 over n times 2n, n minus 4 over 2n times 2n, 1 over 2 times 2n. Now, I don't know if any of you guys got to this point yesterday on the assignment, but some students start to do this distribution and canceling in their head.
I just wrote it right beside the problem.
Yeah. Yeah, and that's this method of having something where you multiply by that to get rid of fractions is something that's common. We start to do that. We do that here. We do it with complex fractions. It's something that we use as a tool now. We've learned it in Math 3, so we're going to save that tool in our brains and we're going to keep using it. And by the time I would get students in my calculus class, they wouldn't write the work down. They would always do it in their heads. It ends up being a really nice simplifying tool. Where you can do things quickly. So I wouldn't rush that. I would show your work as often as you need to make sure that you can be accurate. But once you get to the point where you can do these without writing that work down, that's fine. Okay? All right, so my n's cancel. My 2n's cancel. My 2's cancel. Okay. So what do I have for the first part?
8 plus 48.
8n plus 48. Oop, it's not squared though, it's times 2, yeah. Okay, plus, and then nothing to multiply here, so just n minus 4 equals n, okay? So if we combine like terms, what do we have?
8, not n plus 4, 4, not n plus.
Okay? And then what should we do? Subtract the 44?
No, subtract the 9.
Subtract the 9? Yeah, you could subtract the 44, it wouldn't be wrong. So 44 equals negative 8n, right?
Yeah, that's not going to be a whole number.
Yeah, it's going to end up being a fraction, which is okay.
5 times, it's 5.5.
Wow, that was a lot of math. I'm going to do, oh, you're right, though. Yeah, that's nice. Okay, I'm going to do, I'm just going to leave it as a fraction. Can we reduce this at all?
Yeah.
Divide by 4, so 11 over 2. Leave the negative in the front.
Do we have to do it as a fraction? Or can we write it as a fraction?
You can do decimals. Typically what I say is if the decimal is one where you don't have to round, then decimals are fine. 5.5. And then otherwise I would do fractions.
But it's
Yeah, I typically do fractions anyway because I'm too lazy to get out a calculator.
You're right.
yeah, normally I would. That one I just knew.
Yeah, you did that one really fast in your head, and I'm not that fast with dividing in decimals. So
It's because in third grade, our third grade teacher made us memorize a song for like every single multiplication thing. And so I knew like
Yeah.
every time someone was
mine did too, but I don't remember them.
I remember all of them. And I remember one was the
Wow.
one was Jude on that beat, one was the Whippin' Day Day, one was Twinkle Twinkle Little Star.
Oh wow.
Ours was just some cheesy song. It was like 6 times 8 equals 48.
Yeah,
Trying to rhyme.
I think I had the same ones actually.
3, 6,
That means they're.
15,
Y'all had songs.
All right, here's the next one. Okay, so m minus 1 over 3m squared minus m minus 1 over 6m squared minus 2m, we're making the denominators a little bit more difficult this time, equals m squared minus m minus 12 over 12m squared minus 4m. If we compare the denominators in a second, though, it's not as bad. So before we compare the denominators, we have to get them into a form where we can truly compare them. So what should we do with them? Factor them. So what type of factoring should we do? GCF. Okay, what's the GCF of this one? Not 3, just m. So take out just the m, what's left over?
Thinking about all of them. In
3m
minus 1.
minus 1. Okay, what's the GCF of this one? 2m, what's left over?
3m minus 1.
Okay, what's the GCF of this one?
4m.
4m, what's left over? Okay, so now we can tell they're actually pretty comparable. Okay, so can you guys tell what the excluded values are? There should be 2 of them, right? Positive 1/3, okay. So 1 divided by 3, okay. What about the m in the front? 0. Good, okay. So, and then our common denominator would be 4m, yeah. 4m and 3m minus 1. Okay, so 4m and 3m minus 1. Okay, so it looked pretty bad in the beginning, But then once we worked with each of the denominators, we realized it's not terrible. Yeah.
How did you get 1/3?
So we said positive 1 because of this part, and then divide by 3. So positive 1 divide by 3. And the reason we got that is if you do 3m minus 1 equals 0, then to solve it, 3m equals 1, divide by 3. So you just have to think about what would make that factor equal 0, and then that's the excluded value. Yeah. Okay, so I'm going to say this whole thing multiplied by 4m times 3m minus 1. That's what I'm multiplying it by. I don't have a lot of space, but I don't feel like writing this a bunch of times. So when I write each of the fractions, I'm going to write the denominator in the factored form because I want it to be easy to cancel. So there's the first one times 4m, 3m minus 1. Do you guys see how I'm writing it so it's easy to cancel? Minus 1 over 2m times 3m minus 1. Yeah, so far I've only canceled out the stuff that was really easy to cancel out, and now I'm going to focus a little bit more. So I canceled out the parentheses because they were identical. We can cancel out the m's. So multiply by 4. Okay. Okay, so this one, the m's, and then 4 and 2 can reduce. So we have minus, and then 2 times 1. And then over here, everything canceled, thank goodness, because the top was going to be not fun to multiply. So our equation has an m squared, and it has m's, and it has numbers. And anytime we see all three of those things, what should we think about? Factoring. And for us to be able to factor, what does the equation have to equal? 0. So we need to take the 4m and the 6. We need to move everything over here so we can make it equal 0. So I'm going to minus 4m. Going to add 6. So the part about today's assignment that students have historically not liked is that some of the problems end up being quadratic equations, which requires factoring to solve. Yeah. So we're looking for two numbers that multiply to a negative 6 and add to a negative 5.
6 and negative, or no, 1 and negative 6.
And that's the factored form, that's not the answers. So what are the answers? And those answers are not the excluded values, so they're good. So if you think about how the excluded values work, of all the numbers in the world, there's only a couple numbers you can't have, so most of the time it won't make a difference. It truly would be, I would have to choose a problem specifically where the excluded value and the answer are the same. That sounds like a bonus question. Okay.
Just make sure you like put in parentheses.
It just means that every time you got to check, and the one time you don't check is going to be the time it happens.
And then the
Yeah.
answer's just no solution if you give it.
And then if that happened, now it could be something like this where one of them is the excluded value and then one of them is not. Yeah.
Put m equals no solution, m equals.
Well, you wouldn't put no solution. You would just be like if one of the excluded values was -1, you just cross this one out and then you'd say like, oh, m equals 6 is the only answer. So you'd only say no solution if the excluded value like canceled out the only possible answer you could have, and now you just don't have an answer. Yeah. Yeah, good question. Okay. How are you guys feeling about this?
I think of one.
I feel like we
Feeling
can do
okay?
a 30-question sheet right now.
I have punchline sheets, and I have two options for you. Okay, so you guys get to choose, which means that if you want to do more than one, you can for extra credit. So